Hey everybody, this is going to be our first lesson here. Trying this out for the first time, I figured with the notes as I'm going over material, it'll be much easier for me to sit and explain and go through the notes. If you do look on the classroom, I have a couple of different files posted. You have completed notes, which is what I'm going to use. You have blank notes as a Word document, which you can type in as you go through the notes if you'd like. And then there's also a worksheet packet. All of the materials do not have to be printed out. Don't worry about that. You can write things out and fill it in as we go. All right, and you have the video here posted for you, so feel free to go back and listen to anything that you missed and to get any notes that you may have missed. All right, so the first part of our next topic, we're going to talk about what is equilibrium. So we're going to talk about two different types of equilibrium, chemical equilibrium and physical equilibrium. Chemical equilibrium, we have two requirements in order for something to be at chemical equilibrium. So this is when a reaction is taking place, you put the reactants together, you put the products together, and then we would consider it done. We don't see any more product being made. Well, what's actually happening is that reaction is going in forward and reverse and forward and reverse. So we talked a little bit about this during kinetics when we discussed a reverse reaction, specifically the activation energy of the reverse reaction. So now we are taking those reactions and we are going to push them forward and we are going to push them in reverse. So we're going to talk about things that we can do to make more product and push that reaction forward, or to make more reactant and push that reaction in reverse. So the two things that have to happen, or the two things that are happening when a reaction, a chemical reaction, is at equilibrium. Number one, the concentration of the reactants and the products are constant. Okay, so that means they don't change anymore. They're at a point where they don't change. So if we take a look at this graph is a great example of that first idea. So what we see here is a line representing the concentration of the reactants and a line representing the concentration of the products. The reactants start off very high and the products start at zero, because before the reaction even starts, we don't have any product, but we have a whole bunch of reactants. So now as time goes by, the reactants get used up. All right, so we can see that concentration decreasing. While that's happening, the amount of the products that we have increases, which makes sense because if we're using up our reactants, we are making the product. Then we get to this point right around here. The lines level out. So what this graph shows is at the dotted line, the concentrations are constant. Okay, the concentrations are constant. So we can see that leveling out at that point. So we could say that a reaction is at chemical equilibrium at this point. The second requirement, or the second thing that happens during chemical equilibrium, is that the rate of the forward reaction equals the rate of the reverse reaction. Okay, so now what are we talking about, forward and reverse? We're going to start to see a symbol of a double-sided arrow more and more now, which means that reaction has the ability to go forward and reverse. So think about this, the rate of the forward and the rate of the reverse reaction. Whatever is being done is also being undone at the same exact rate. So let's say you're at your locker taking books out of your bag and putting textbooks and binders into your locker. But let's say you have a friend standing there, and for every book you put into the locker, your friend takes one out. You put one in, he takes one out. And this keeps going and going and going and going. That would be the work going forward equaling the work going in reverse. So it's basically a stalemate. You have a reaction that is producing product, but then it goes right back to the reactants. So whatever is being done is being undone. Okay, so we just have to remember that the reaction has that ability. So in addition to chemical equilibrium, we also have physical equilibrium. And this is when you have different states existing for a type of matter, for a substance. So the best way to think about this is phase equilibrium. All right, so if you remember when we learned about our heating and cooling curves, right here and right there. Those two flat lines were when the phases were changing. That would be phase equilibrium. So melting and freezing is one equilibrium, and boiling and condensation is another equilibrium. Another thing I would mention is to also remember the temperatures, okay? Temperatures are very important with this. And for water, don't forget for water, we have 0 degrees and we have 100 degrees. We can't forget our information for water, okay? So very important that we do remember that. Also, we have something called solution equilibrium. When you dissolve something into water, you're not making a new substance. It's not a chemical reaction. You're simply taking a solid substance and breaking it down into its individual ions in that liquid, in the water usually. We know that we can boil off the water. We can evaporate the water and regain our original solid. So we're not making anything new. That is a phase change. So a saturated solution is when you have an equilibrium between the solid and the aqueous phase. All right, I'm underlining here. You guys know I love highlighters. I would absolutely recommend highlighting these little parts of the definitions. So if you can, keep a highlighter handy whenever we're going through, you know what I'm gonna do. I'm gonna keep underlining and circling certain things. Okay, so again, solution equilibrium, saturated solution. As soon as you hear the word saturated, you know you have an equilibrium between what is undissolved and what is dissolved. Okay, so those are our basic definitions of chemical and physical equilibrium. Okay, now moving forward. In tomorrow's lesson, we're going to start talking about Le Chatelier's principle. All right, Le Chatelier's principle. This is a principle based on a reaction at equilibrium where we can basically come along and mess that equilibrium up. So if you have a reaction that has hit equilibrium and you look at what was produced and how much product you have, and you say to yourself, you know what, I really would like more product out of this reaction. This is not as efficient as it can be. There are things that we can do to actually push that reaction more and get more product. There's also things we can do to push that reaction in reverse, okay? Now, those pushes, okay, those things that we can do to push the reaction in different directions, the things that we can change, we call them stresses. All right, a stress is a change that can occur to a reaction at equilibrium, which will take it out of equilibrium. Okay, so imagine you're standing on one foot, you're balanced, and someone comes along and gives you a shove. They just knocked you off of your physical equilibrium. Well, those reactions, they've hit a point where they're going in the forward and reverse reaction at the same rate. They're kind of balanced out. The concentrations are all constant. And then something comes along and messes that up. Those three stresses are going to be changing the temperature, Concentration. When we say concentration, we're talking about adding or removing something from the reaction. So adding a little bit more reactant will give you more product. Taking something away, the reaction wants to replace it. Okay, so when we say concentration, we're talking about adding or taking away something from the reaction. And then pressure. Pressure, what do we know about pressure? Only affects gases. So you need to have a reaction that only contains gases in order for it to have any change. Now we've stressed it. We've messed it up. What does the reaction do? The way the reaction responds to that stress is called a shift. Okay, think about it. What can a reaction really do? It can go forward, it can go reverse. We call that a shift. So if we say that a reaction is shifting to the right, that means the reaction's pushing forward. All right, just left to right. The reaction's pushing forward. If we say a reaction shifts to the left, that means a reaction is pushing in reverse. It's going backwards. So that's that backwards direction we were talking about. So we might have a particular reaction. I know I always use the example of like baking a cake because that is a chemical reaction. If we take all the ingredients and mix them in a bowl, and I know we've discussed this before, and then I just leave that bowl on the counter, I'm not going to get a cake. There's no way. What do we need to do? I need to add heat. I need to increase the temperature. When I increase the temperature of that mix, I will now push that reaction forward to get to my final product, which will be the baked cake. Without that push, that stress, we're not going to get that final product. Okay, so there are certain things we're going to do to push that reaction forward and reverse. So for example, at the bottom here, I have a few, just an example. This particular reaction has hydrogen gas and chlorine gas, plus some heat. So this is endothermic, because the heat is on the reactant side. And we are making HCl gas. If the reaction shifts to the right, if we do something, I'm not saying what yet, because we'll learn that in the next lesson, but if we do something to make this reaction shift to the right, that means we're making more HCl. Okay, we're pushing it forward. So we would say that the concentration of HCl increases, the concentration of H2 and Cl will decrease. Okay, so if I push a reaction to the right, if I shift it to the right, that means this reaction is progressing forward and I'm making more of this. So that concentration increases. Well, if I'm going to make more of this, I have to use up this. So the amount of hydrogen and chlorine will decrease. Then just the opposite. Let's say we do something to this reaction and force it to go in reverse. Okay, we add a stress and the reaction shifts to the left. Well, if that happens, if a reaction shifts to the left side, that means I will be making more hydrogen and chlorine, and I will be decreasing the amount of HCl in that reaction because it'll be breaking down. It'll be going in reverse. So again, the concentration of H2 and Cl2 increases, the concentration of HCl decreases. Okay? So this is all very new, and go figure, this is one of the most abstract topics of the year, and I am not able to sit there face to face with you in class to go through this. So this is going to take us a couple days to get through with a couple days of practice, and I'm going to have videos where I literally walk you through problems that are in that worksheet packet. So if you could download that PDF, get that onto your device, get some paper ready so you can copy down some of the questions. That would be outstanding because then you'll be able to have those answers written down for your records. Now, after this, you have a very short Google form to fill out. You have a couple of multiple choice questions. Now, I know some of you have been jumping ahead and trying to complete this. I actually shut the responses off because some of you are trying to do the work without actually learning the material that goes with it. I need you guys to please pay attention to the directions and make sure that all materials are there. I really appreciate the fact that you guys are trying to get ahead with the work. But I did send out a message saying to just please wait and make sure the video is posted, that all materials for that day are posted in order to complete the work. They all will go together. All right, it is very important. So if anybody submitted that work already, I deleted the responses. I got rid of them because some of them did not have answers. Some of them had incorrect answers, and I don't want to hold that against anybody. But I need your cooperation in that in order to make sure you guys are understanding what you're doing. The other thing is make sure whenever you have work to submit that you submit it correctly and you also mark it as done, okay? If I don't have work from you, I'll let you know. But I know there's a couple things that you have to do just to make sure the work has been correctly submitted, and you want to make sure that you mark it as done as well. All right, guys, I think that's it for today. For our next lesson for number 2 and number 3, we are definitely going to be working more on Le Chatelier's principles and these next few pages with temperature, concentration, and pressure. As you can see, if you look at the notes that I've posted online, I don't have everything filled in because these are examples. So we're going to walk through these together and we'll go through and fill in the rest of that. So you should be all good to go. And again, you do have the Word document, so please feel free to have that on your laptop or device, whatever you're using, and to type in as you go. All right, guys, have a great day. Hope everyone's doing well, and I'll talk to you guys soon. Take care, guys. Bye.